So we can use definite integrals to find the area between two points. So x greater than or equal to a, less than or equal to b. All right. So let's suppose I am given x's and I'm given some curve over here, which goes like that. And it starts, and let's say I want to find from a until b for this curve, the area underneath the curve. The curve will be given by f of x, like this. And so the integral of f of x dot dx from a to b is how we write it, will be given as the area under the curve. Okay. Let's do a quick example of this. I have my y-axis, I have my x-axis, and I have a curve y equals x squared plus x cubed plus x squared minus 2x. All right. So this curve is doing something like this when x is 0, y is 0. So it's going to pass through the center and it's just going to turn like that. So something like that. I'm going to try and draw it accurately as far as possible. Don't know if I'll do that, but let's see. Okay, so it's basically just passing the center like that. Some kind of curve like that. Okay. Now, we want to find, the question is saying now, find the area between x greater than or equal to negative 2, less than or equal to 1. Okay, so negative 2 is over here, and this is going to be 0, and 1 is maybe somewhere over here. We don't know where it is, right? All right, so looking at this function over here, let's suppose I quickly just see if I can factorize this. So y is equal to, I take out x, I'm left with x squared plus x minus 2. And then I'm left with x minus x plus 2, x minus 1. And so therefore, x equals 0, x equals minus 2, x equals positive 1. Just like we expected, those are my x-intercepts. Okay. I'm making y equal to 0. So if this is actually 0, then we end up solving for x. And so those are all my roots, all my x values for the function over there. And so what I need to do now is I need to integrate it from negative 2 until 1. And that's going to be, so from negative 2 until 1, I need to find the integral. So what I'm going to do is integrate from negative 2 until 0 using the definite integral method, right? So here we go. From negative 2 until 0 of x cubed plus x squared minus 2x dot dx. Okay. And when I integrate this, I have to increase the power, right? So this is going to become x to the power of 4 over 4 plus x to the power of 3 over 3 minus 2x squared over 2, which will just become x squared. And I put a bracket around it, starting from negative 2 until 0. And I want to find this area underneath the curve. Once I have this, I substitute the 0 first, and then I subtract the substitution of the negative 2 into here. So 0 will go in there, and you'll end up with 0. And when I substitute negative 2 in here, it'll come to negative 2 to the power of 4 over 4 plus, so it'll be minus 8 over 3. And then minus 2 times minus 2 is 4, so it'll become negative 4. And so that'll become minus 2 to the power 4 is 2 times 2 is 4, 4 times 2 is 8, times 2 is 16, divided by 4 is 4. Minus 4 will cancel out with that 4 there. So this is technically going to become 4 and 4, leaving me with positive 8 over 3. So that means that this area underneath here is equal to 8 over 3 units squared. Because I'm looking for the area between -2 and 1, I need to also apply the exact same method for this area at the bottom. And I have to integrate this function between from -2 and 0, but this time from 0 to 1. So for this part, we integrate from 0 to 1 of that whole function, x cubed plus x squared minus 2x, which we've already done. And then we've got x to the power 4 over 4 plus x to the power 3 over 3 minus x squared. And now we substitute 1 in there, and then we subtract it from 0. If I put 0 in there, the whole thing becomes 0. If I put 1 in there, I'll end up with 1 over 4 plus 1 over 3 minus 1. And that's the same as 12 over 12. Or I could just work this out, multiply this by 3. So it's 3 plus 4, which is 7. 7 minus 12 is negative 5 over 2. Right, so it's going to be negative 5 over 2, which will be this area. Notice this area is a negative value, right? Negative 2.5 or negative 5 over 2 units squared. This area. If I want the total area, what I need to do is I need to add the absolute value of each of these. And so therefore, the total area will actually come to the following. It will be simply adding those two fractions and it's positive. So 8 over 3 plus 5 over 2. So 2 times 8 is 16. 16 plus 15 will become over 6. 31 over 6. It's 8 over 3 plus 5 over 2. Just double check me here. This is 5 over 2. This should be 5 over 12. This should be 5 over 12. And this is going to be 5 over 12. That makes more sense. And then this is going to multiply by, so let's just sort that out quickly. That's going to be 12 there. So we're multiplying this by 4. We end up with 32 minus 5 over 12, which will be 27 over 12. All right. If I can add correctly. Oh yeah, we're plusing it. Let's not forget that. We're plusing it. So it's going to be 37 over 12. Final answer there. Okay. And that's how we would find the area using a definite integral. Okay, just a little bit of trial and error there.